So today we are returning to past paper questions for APs and GPs. After my dysfunctional brain in the last lesson, I figured we should have another go round on these. Okay, a reminder that everybody's human, including your teachers, and everybody makes mistakes. So the last lesson was a good example on how to deal with mistakes when you make them. Hopefully this lesson will go a bit more smoothly. So we're starting out with a warm-up question, and then we will move up into some more complex and funky questions to actually stretch our brains a bit. Okay, so first question. First and second terms of a progression are 4 and 8 respectively. Find the sum of the first 10 terms given that the progression is part 1 arithmetic and part 2 geometric. So a reminder that APs are all about addition. Okay, and because they are nice and predictable and reliable, we have a set of formulas that we can use. So an AP we need to state, and then we need to be very careful on doing our summary. So first term is A equals 4. Second term is U2 equals 8. And our first friendly formula, U2 also equals A plus D. Right, so in order to do the sum of the first 10 terms, we're going to need N, 10, A, 4, and D. But here we have a lovely equation popping out of our first line here, which is why we do things on one line. We know that 8 equals 4 plus D. There's our equation, but we already have the value for A. So subtracting 4 from both sides, we can see that D equals 4. So now we have our A, our D, and our N. So we're ready to sum for 10. Sum of 10 equals. Now the formulas are in your MF9 formula sheet, but it is not a good idea to rely on those because you need to have it in your brain. You need to be comfortable with it and what is required in the formula. So sum of 10 is half N. So half 10. 2A plus N minus 1 D. And we have a value for D. And then we can put all of that into our calculator. One time, one calculation, keep your accuracy, and we get 220. So for first term and second term 4 and 8, if it's an AP, our sum of 10 is 220. So now we get to do the same thing for a GP. Remember, GPs are all about multiplication. Again, they are reliable, they are repetitive, and because of that, they are predictable, and we have another set of formulas. So APs and GPs are very different to sequences at IG. This repeatability is just wonderful and makes life so much easier. So now we need to state we've got a GP, same summary. A equals 4, U2 equals 8, but now this equals AR because we're dealing with a GP. AR to the N minus 1 is our nth term. So when N is 2, it's R to the 1. Funnily enough, we can follow exactly the same pattern. We know that 8 equals 4R because we have our value for A. So R equals 2. We then have to do the sum of 10 terms for a GP. So again, nice and predictable. S10 equals A times. Now I have to admit I always do 1 minus R, not R minus 1 because I just find it easier to remember based on that sum to infinity. So I would have 1 minus 2 to the 10 all over 1 minus 2. And the thing is, I'm going to be putting this all into my calculator anyway, one time. So it's not like I'm going to be dealing with negatives and positives and who cares what. Okay, so when I plug this all in, I get, hopefully you also get, 4092. So, one little thing that I want to highlight here. See here. Okay, this is a build a habit. Remember, if R is a fraction, it has to be in the brackets in order for that exponent to be applied onto the numerator and the denominator. So rather get into the habit of always putting your R into a bracket to ensure that you don't have to remember just when it's a fraction. Okay, safest bet is to substitute everything with brackets, and then you know you're never caught short. Okay, have we got some warmed up brains? Are you ready to go, ladies and gentlemen? Some more interesting questions. Okay, so a reminder, if you are in this lesson and you haven't gotten to APs and GPs yet, we're just extending. If you're already past APs and GPs, great revision. If you're doing APs and GPs at the moment, perfect timing. So, we've established in the last few weeks of APs and GPs that your summary is key. So let's look at a funky question. In an AP, the sum of the first n terms, Sn, equals n squared plus 8n. Find the first term and the common difference. Now, we have said that whenever we summarize, we always summarize all the way to ADN for an AP and ARN for a GP. So we would be good students and we would put half n to A plus n minus 1d. And then we get a little bit sort of wobbled because what we've always said is that in our summary, pop out our equations. And here we've got a whole lot of variables and only one equation. One equation can only solve for one variable. So that is the beauty of this question, in that it is something different. This one, we're going to have to rethink our understanding. We're not going to use this for this question. We're going to think back and say, what does Sn actually mean? It means the sum of that many terms. So if we said the sum of one term, this would equal 1 squared plus 8 times 1. Again, substitution in brackets. Sum of one term, therefore, equals 9. Okay, that's all very well and good, but what does the sum of one term mean? Remember, we always start summing from the first term, so the sum of the first term is the first term. So S1 equals A equals 9. Brilliant. Okay, now we've got this linkage of N going all the way through, so we could also plug in S2, because we understand that S2 is the sum of the first and the second term. So S2 equals 2 squared plus 8 times 2. So 16 plus 4, S2 equals 20. And you see the magic, because we know that S2 equals A plus U2. Well, 20 equals 9 plus U2. U2 equals 11. How does this help us? This helps us because we know what U2 is, because we've done so many of these summaries. It's like second nature now. We know that U2 equals A plus D. So 11 equals 9 plus D, and D equals 2. And they've asked us for the first term and the common difference. First term equals 9. Common difference equals 2. And that's why I say this question is a little bit more fun and games than usual. Because in 98% of the questions that you do, you're going to be using your summary, and your equations are going to be popping out of your summary so beautifully nicely. Okay, but in this case, we were linking to our understanding of what a sum is, rather than just dealing off the summary. So let's add a little note in there to note that. For future reference, we're working on So it's important that at every stage of your maths, you understand the conceptual information behind what you're doing. You're not just plugging in numbers and getting calculations. Do you understand what we mean by term, a UN, or a sum, an SN? Okay, all right. Let us move on to the second part of this question. It's also more fun. Okay, so in a geometric progression, the second term is 9 less than the first term. The sum of the second and third terms is 30. Given that all terms of progression are positive, find the first term. Now that is a lot of information. So we breathe, we smile, we say, I know how to summarize. GP. It's always good to ground yourself so you know which set of formulas you're using. The second term is 9 less than the first term. So U2 equals A minus 9. But we never leave it at that because we have a U2, so we have equals AR. The sum of the second and third terms is 30. Well, this is not an SN because we excluded the first term. It is very simply second term plus third term equals 30. Given all the terms are positive, find the first term. So find A. Right, U2 plus U3, we need to get this down. AR plus AR squared. And now you can see my magic works a little bit, yeah? Because on this first line, we have A minus 9 equals AR. And on the second line, we have 30 equals AR plus AR squared. And we breathe a big sigh of relief. Because if we have two equations and two variables, we can get to an answer because we can solve them simultaneously. So how are we going to do this? We are going to get our brains straight first. We have A minus 9 equals AR. And we have 30 equals AR plus AR squared. Right, so let's have a think about it. It's all a bit ugly, really. But this one we can go relatively straightforward to. R equals A minus 9 over A. So then we can substitute in and we can calculate for the first term. So just like in coordinate geometry, it is really nice to keep track of what you're doing. So substituting in, we have 30 equals A minus 9 over A, plus A minus 9 over A squared. Now, usually we say avoid this, don't substitute something in and square it, but there's a lot of ugly options here. So let's see what happens in magic. See here and here, we've got some cancellation going on, which makes life a little bit less ugly. So we have 30 equals, those two cancel, A minus 9 plus, then we just have A minus 9 squared over A because the second A has cancelled. So 30A equals A squared minus 9A plus A squared 9A minus 18A plus 9 nines are 81. We're heading towards a quadratic. So if we get to our quadratic, we get 0 equals A squared and A squared minus 9A minus 30A minus 18A gives us minus 57A plus 81. Whee! They do not like us very much in this one. Okay, but we can do it because our 2 is prime. So we know we've got a 2a and an a. So we need factors that add up and give us 57s. So what have we got? 1, no, 2, no. 3 looks interesting. So 3 and 27. Yeah, because 2 times 27 is going to give us 54 plus the 3. So 27 and 3 like signs, both negatives. So if you need a revision of quadratics, shout. Okay, so here we have a bit of an issue because we have a equals 2/3 or a equals 27. What's the answer? So here we go back to the question. And we see here that there's a given that all the terms of the progression are positive. So in this case, we didn't end up with a negative a, which we could rule out. We've got 2 a's. But there must be some way of still figuring out which one of these is the answer. And there is. If these are our a's are both positive, great. But for all the terms of the progression to be positive, r must be positive as well. So, if a equals 2/3, what does r equal? R equals, and there's the problem, 2/3 minus 9 over 2/3. That equals minus 5. That's not going to work for us. Let's double check. If a equals 27, r equals, oh, this is much better. R equals 2/3. So, we know as all terms positive, r equals 2/3 and a equals 27. This is the only answer that actually satisfies the conditions given in the question. So you can't just stop at solving your quadratic. You have to actually interpret. So whether it's one of the answers to your quadratic is 0 or 1 or negative and therefore it doesn't apply, or in this case, where life gets a whole lot more easier, a whole lot more interesting, where you actually have to do further calculations, you must go all the way to the end. When they give things like this, when they give a given that in the question, it means they are helping you to figure out your answer. Okay, you're going to get options created, and you use whatever your given that statement is to figure out which is the correct option. Okay, so another interesting question. Are the brains doing okay? Are we ready for another question? We've got one more two-parter question to finish off for today. Right, so we have some happy brains. Let us get to another question. So this is a more classical AP-GP question. Okay, so time to take a breath. So, first, second, and last terms in an AP are 56, 53, and minus 22. Find the sum of all the terms. So, again, we always start with our summary. AP, first, A equals, second, U2 equals, and last, who's the last? UN. Remember subscripts, hey? Must be subscripts. A is 56, U2 is 53, UN is minus 22. Now, the thing is that we never leave our summary like this. We always take it AP, so we're going to A, D, and N. So U2 equals A plus D, because 2 minus 1 is 1, and UN equals A plus N minus 1 D. Right. In order to find the sum of all the terms in the progression, we need Sn. Okay, so we're going to need an N. We're going to need A's and D's. In this case, though, we've got a special friend come to visit the last term. Okay, so, but at the end of the day, we have to have N, because we can't sum all the terms if we don't know what number of terms we have. So how are we going to get that? Well, here's an N including formula, but it needs an A and a D. Well, A is fine, D we don't have. Can we get it? Yes, we can, because again, our equation pops out. So, for value of D, we know that 53 equals 56 plus D. So D equals minus 3. And those warning bells are ringing because D is negative. So you've got to be very, very, very careful when you substitute. Right. So we have A, we have D, we have a value for our last term. So now we can calculate his position. So for number of terms, we know that minus 22 is the value of our last term, and we would calculate him by A, 56, plus N we don't know, N minus 1 times D. Note the brackets. If you do not have the brackets, you are saying N minus 1 minus 3, which is N minus 4. You must have the brackets for the multiplication. It is a crucial, crucial, crucial thing. Do not neglect it. Okay, so now we can have some fun. So minus 22 minus 56 gives us minus 78 equals minus 3n plus 3. So moving our 3 across, dividing by our other minus 3, n equals 27. Right, and we're happy because we should have a nice round number for n because it's a count. So we now have the number of terms, we have A, we have D, we have N, so we can do the sum of all the terms. And here we're going to use that less frequently used formula, but again, it doesn't matter that you don't necessarily know it because it's in your MF9 and you are aware that there is a formula for the sum using the last terms. If you use the other formula that we always use, half n, 2a plus n minus 1d, there is absolutely nothing wrong. But just for the fun of it, in this case, we're going to do S27 equals 1/2 n, and then a plus l. Substituting with brackets to keep things safe. Plug it all into a calculator one time, and we get 459 as the sum of all our terms. So just to prove my point, as it's fun to do that sometimes, if we had done it the other way around, we would have had S27 equals 1/2 27 2a, so 2 times 56 plus n minus 1 is 26 times d is minus 3. And if we put all of that into a calculator, we also get, magically enough, 459. So again, I say, it doesn't matter which one you use. In this case, you have the last term, so you can use that other less frequently used formula. But if you like to be a creature of habit and always use your full out SN term, then go for it. You'll get full marks either way. Okay, so one little question left. What are we facing for the end? Something even more interesting. The first, second, and third terms of a GP are 2k plus 6, 2k, and k plus 2, respectively, where k is a positive constant. Find the value of k and find the sum to infinity of the progression. Righty-ho. Well, we don't freak out because just because there's letters in it doesn't change anything. Letters act like numbers. In some cases, letters are simpler than numbers. Right, so we get started. Part 1. Find the value of k. Well, first off, we want to do our summary. So second and third. A equals, U2 equals, U3 equals. And then 2k plus 6, 2k, and k plus 2. Okay, but we also know that this equals AR, and this equals AR squared. So, we have all sorts of things going on here. Okay, but we've got to be clever. Because in this case, we've got K's and A's and R's, and K's and A's and R's, and K's, A's and K's. We've got 3 things going on. So let's think a little bit, which is why, of course, we're doing this question. Remember how we had a question earlier on that made us think about what is the sum? The sum of one term is the first term. The sum of 2 terms is the first term plus the second term. So this question is making us think about how do we progress from one term to the next. We multiply by R. So second term divided by the first term is R. Third term divided by the second term is R. 10th term divided by the 9th term is R. 100th term divided by the 99th term is R. Now we're getting some fun. Because if everything always equals R, then everything always equals itself. Remember, it's a common ratio. It repeats. So if we say second term divided by the first term equals R, 2k over 2k plus 6. But we're also saying that R equals the third term divided by the second term. And now, look what we've got. We've got 2 little equations, we've got 2 variables involved, and we've got R equals in both cases. So life becomes so much easier. We can just equate our k bits. So 2k over 2k plus 6 equals k plus 2 over 2k. So let's clear fractions by multiplying up. So 2k by 2k is 4k squared equals, let's not overface ourselves, k plus 2, 2k plus 6. Remembering to insert brackets to preserve terms and get our right number of terms when we multiply. So 4k squared equals 2k squared plus 4k plus 6k gives us plus 10k. 2 times 6 is plus 12. Right. Everybody onto one side with a positive k squared to make life easier. Brings them all over here to 2k squared minus 10k minus 12 equals 0. We certainly don't want to make life uglier than it is. These are all even. So k squared minus 5k minus 6 equals 0. And then we understand the joys and the wonders of quadratics because we have simplified it to something much more approachable. Equals 0. Factors of 6 which subtract to 5 is a 6 and a 1. We have minus 6, we have unlike signs, we have a minus 6 and a plus 1. So k equals 6 or k equals minus 1. But remember that we were told k is a positive constant. So, given that k is greater than 0, therefore k equals 6 is our final answer. We are sprinting now to finish off. Okay, so part 2 is find the sum to infinity. So once we've got the value of k, then the value of a and r becomes a lot easier. So a equals 2 by 6 plus 6. which equals 18. R equals 2 by 6 over 2 by 6 plus 6, which equals 2/3. Sum to infinity, that wonderful formula that lets us get to the end of everything, is 18 over 1 minus 2/3. So your sum to infinity equals 54. So, a little bit smoother than last time. Here, a little note to self that we are. How do we progress from one term to the next? Multiply by R each time. The joy of predictability.